All right, hello everybody, привет. And for those of you who I didn't meet yesterday, yeah, my name is John. I work as an iOS developer at Hyper, and I also work on several Swift open source developer tools. And this is an area where I've started to become really interested over the last couple of years since the introduction of Swift, where I feel there's a huge opportunity for us as the community to create really cool tools that we can use to increase our productivity. So today I'm here to talk about Swift scripting, and this is another area of great interest of mine where I feel like we can really easily put together these fun little tools that can increase our productivity and make our life as developers easier and more fun. But when you see this initial slide here and you read this title, Swift Scripting in Practice, you might be asking yourself one of the following two questions. First of all, you might be thinking, what is this scripting thing really about? And why should I care about it? What is it useful for? And, you know, what are some of the applications? And secondly, why use Swift for scripting? I mean, there are great languages out there already for scripting that have had a long history of this use. Why bring Swift, which is very complex, you know, has lots of features? Why bring this type of language into scripting? And so my goal today is to kind of answer these questions in a way and also give you some tips and tricks along the road for how you can use Swift scripting in a nice way. And also, if you've tried it before, to kind of give you some tips on how to overcome some of the hurdles that you might have been facing in terms of performance or how to use it. So let's start with the first question here. Let's dive into why use scripting. What is it good for and why should you care about it? Well, for me, scripting is a great way to automate certain types of tasks. You know, as developers, we have a lot of tasks that we have to do. You know, sometimes we have to write, you know, new classes, refactor, do tests, etc. But one thing that we're really looking to avoid as much as possible are things that are really repetitive, right? I mean, as developers, we hate repetition. That's why we do things like abstract things out into nice classes. We don't have code repetition. We hate to repeat ourselves and do things over and over again. When we're doing things over and over again, things also tend to become quite error-prone. Because, you know, we're humans, all of us in here, as far as I know, at least, as long as there are no robots in here, we tend to make errors. And if we do things over and over again, those errors tend to accumulate and become even more big, right? And finally, doing repetitive tasks is very boring. And I don't know about you guys, but I like to have fun when I'm coding. I don't want to do things like these chores, annoying, repetitive, boring things. And this is where scripts can really help you out to make these things a lot smoother for you, which will probably increase your productivity and make things a lot more fun. So, as promised, this talk is about Swift scripting in practice, how we can use it in some real-life scenarios. So let's take a look at one of those. For example, you might be working with a designer or someone else in your team, and you might get a huge set of files that you find yourself in the need of renaming. You know, not everyone is agreeing on the same naming conventions, and sometimes, you know, you can get a big set of files that, you know, are kind of incorrectly named maybe, from your perspective. So let's say that you're going to do a big animation in one of your apps. And this animation has lots of different frames, you know, and your designer goes off and creates this very nice sequence of PNGs. You know, a lot of frames, 100 frames, you know, it's going to be super smooth, 60 frames per second, beautiful. But as the developer, you notice something here in the sequence which really drives you a bit crazy, right? And most of you have probably spotted it. It's right there, right? This index, or this sequence starts at index 1. Oh my God, what are we going to do about this, right? How can you start something at index 1? It doesn't make any sense. Well, turns out, for most people who are not programmers, starting to count at 1 actually makes sense. You know, 1 apple, 2 apples. But for us, that would be pretty terrible. If we're going to do this in a for loop or something in the app, we don't want to start at index 1. It would make us feel, you know, not very nice. So we have a couple of options here. We can either run over to our designer's desk and start yelling at this person and be like, what are you doing? You know that you need to name things at index 0. Come on. not a good idea. We want to make sure that we are nice to our coworkers and not yell at them. So this is a great case where instead of being frustrated or something like this, we can just go ahead and script it. We don't have to manually rename all these files. That would be super boring, super repetitive, and very error-prone. Instead, let's write this very simple script to take care of it. What we're going to do is we're going to access all the files in the current folder and save it to an images variable. Then we're just going to use Swift's enumerated sequence to get access to both the image and the index that we're currently operating on. And then we're just going to rename the file to match the index that we're expecting. That way, we can spend maybe 1 or 2 minutes writing the script, run it, rename all the files at batch, and we're done, right? We don't need to do it manually, and we don't need to be angry at anybody. So that's great. So that kind of answers this question a little bit about what can you use scripting for. And these are the kind of tasks that I think it's really, really nice for. But why use Swift? Why take this language and bring it into scripting? We had great languages already like Python, Ruby, and even things like shell scripting that have been around for a long time. They have great libraries for scripting. Why dive into Swift? Well, at this point, it might be, you might get a little bit emotional. And you might use arguments like, I want to use Swift because it's awesome. I love Swift. It's super great. It's the best language ever created. Well, I mean, it's nice to be excited about a language, of course. But maybe it's not the best argument in terms of when to make a tech decision. Maybe we should try to leave our emotions a bit out of it and make decisions based on facts. But it turns out that there are some really, really good reasons to use Swift for scripting, even without these kind of emotional responses. One reason that you might want to use Swift for scripting is that you get way less context switching. If you're already working in Swift on your app, there's no context switch to go over in scripting. You can still use Xcode. You can still use the same language, use the same libraries. You don't need to start up some new IDE and jump over to a new language and search Stack Overflow. How did I parse strings in Bash again? I have no idea. So you can use the tools that you're familiar with, which is a good argument, I think, because it lowers the barrier for entry. And this is very important when it comes to things like scripting, where you don't want to have a lot of hurdles that you have to overcome. You don't want to have a lot of barriers, because that's just going to lead to you not using it, and that way you lose all this productivity that you might get. So less context switching, I think, is a good argument for using Swift for scripting. The next one is you get access to the same powerful tools that you already know how to use, like core graphics for image manipulation, or URL session for networking, or all the libraries that you've been using, like Almofire, or things for string parsing, etc., or JSON parsing. And it's also nice because, again, lowers the barrier of entry for you. You can get to use familiar tools, and they're really, really powerful. For example, using core graphics, we can split images up or resize them, tint them with different colors. So many cool things we can do with core graphics. But finally, and this is kind of my favorite one, is that you can actually share code between your scripts and your app. And this might sound a little bit crazy, so let's dive a little bit deeper into this topic, and I'm going to show you a practical example. So as I'm working on different stuff, I'm working on some open source stuff, I'm working at my job, doing iOS development, building some libraries, and of course I'm also doing games, because why not? It's also fun to do game development. But when you do games, you have to have graphics. You need to have good, animations and stuff like that, and characters that move on the screen. And, I've been a programmer for a while. I would think that I'm pretty good at it. I'm used to it. I can do it. But I am terrible, just terrible, with anything that has to do with drawing. I can barely draw a stick figure. I have no idea how to draw. Thankfully, I have some friends who are great, and they create these nice little characters that we have in our games that we build together. So we team up, they make the graphics, they make the animations, and I just have to write the code. Well, that's easy, right? So what I do, for example, for animations, is that I create these animation configurations in Swift where we basically load the assets and we set some parameters like the frame count, duration, etc. And then we pass that into the game engine for rendering. So in the beginning, when we were working on some of these games, I was doing these configurations manually because we only had like 5 or 6 characters, they didn't have so many animations, and it didn't change so often. So it was quite easy for me just to do it like this, manually. But as the game grew, and at this point now, we have over 100 animations in this game, it turned out to be very repetitive, very error-prone, and very boring to create all these things manually. I didn't want to do that. So again, this is where I jumped into scripting to write a script that actually would generate these animation configurations automatically. So I wrote the script, which is very simple actually. What it does is that it just loops through all the different units that we have in the game, like the swordsman and the knight and the archer. And then for each one, we access a config file that is on the disk. And this is pretty cool because this enables my graphic designers to actually edit this config file and not have to deal with the code, and can update themselves the duration and things like that. And then we use code generation to actually generate these animation configurations. And there's some great libraries out there like Sorcery and SwiftGen that enable you to do code generation in Swift. So this script, it kind of worked, but it had one big problem. And that was that this array up here, it was kind of hard-coded, and it could very easily become outdated. So as we were adding new characters to the game, or renaming them, or moving them around, this array constantly became outdated. And it would break the script, and it would break our automation, and that was not nice, because the #1 reason you want to create automation is to not have to update it all the time. And we found ourselves needing to update this script all the time. But it turns out that the problem here is that we have 2 sources of truth. We have this array here, and in the game we have an enum, which basically is the same thing, but is what we use in the game. So here we have a class, which is a unit, and it has different cases for different kinds of units in the game. Wouldn't it be cool if we could actually use this instead to generate our animation assets? And the cool thing is, since we're using Swift for scripting, we can. What we do is we just import our game models library right into the script, and then we can just loop through that enum kind, that unit kind enum sequence to actually load all the configs and get the identifier for each one. So that way we have a single source of truth in Swift. When the enum in the game is updated, the script is automatically updated as well. So things become a lot more automatic and a lot easier to maintain, which is great. So, at this point of this talk, you might be a little bit curious and think, oh well, this Swift scripting, it sounds pretty cool. Maybe I should try it out, hopefully. But where do you start? How do you start with Swift scripting? Well, the easiest way to start is just to write a very simple script file. We can call it script.swift, import foundation, write some code, and then run it. You can run it using the Swift compiler right on the command line. If you have Xcode installed, you automatically have the Swift compiler. So you can just run Swift in your script, give it some arguments, and then you will get the results back. The good part about doing it this way is that it's extremely simple, right? You just write a script, you run it, you're done. You can use whatever editor you want, super simple. But there are some downsides. It was mentioned in an earlier talk that there are some performance issues with this. We have to constantly interpret the script every time, but also we can't use frameworks. Well, we can. There's a way to do it, but it's not very practical. It's not very nice. So, and this is like where a big part of the utility of scripting kind of is lost. Because the reason languages like Ruby or Python are so popular for scripting is not because so much of the language, it's more about the ecosystem and all the libraries. So we really want to use frameworks in scripting. And finally, this might be worse for other people than it is for others, but you can't use Xcode really in this way, because Xcode doesn't really play very well with one single file. It kind of needs an Xcode project, etc. I think this is a pretty big deal because you need good code completion, you want to have a good environment for working. So what we can do is we can, instead of using this approach, we can jump over and start using the Swift Package Manager. The Swift Package Manager is a really, really cool tool that you might have used for frameworks or command line tools, etc. But you can also use it for scripts. What you can do is you can start by creating a package and give it the type executable. That way, you're going to get a main.swift file, which you can use for scripting. Then you have a package.swift file, which is basically your manifest. It's the equivalent of like a pod file or a cart file. And in this package file, you can very, very easily add dependencies. In this file, I'm adding a dependency on files, which is a library for easily handling files and folders in Swift. And that way, we're going to get the dependency linked to our script, and we can just use that, which is really great. So I mentioned that you get this main.swift file, and in here, we can just write our code. We can just import files, and in this case, I'm just going to iterate over all the files in the current folder and print them. So it's a very, very simple script. For compiling it, so this type of scripts are compiled as a binary, and then you run it. You just execute Swift build in the folder, and that's going to build the binary. And then you just jump into the build product folder, like .build/debug or release if you're building for release, and you run your script. So it's pretty cool. And this is very, very powerful because it enables you to basically treat your script as a command line tool. You can add dependencies and frameworks. You can use the Swift package manager and compile it. It's way more performant and everything. But it does add some complexity. You know, with scripting, we want things to be simple. In the beginning, we had only one file, you know, script.swift. We could just run it. It was very portable. We could move it any way we want. Things were very easy. But now with the Swift Package Manager, we've kind of made a command line tool instead. We've created this project, you know, with manifest file, folders, etc. It's more complex. It becomes more of a real project. So as I was using Swift scripting and I was playing around with both of these ways of doing it, I found myself thinking, like, wouldn't it be nice if we could still have the power, we could still have all the frameworks that we wanted to use, but instead of having all this complexity, wouldn't it be nice if we had the same simplicity as when we were using just a single file? I think that would be pretty cool. And that led me to ultimately create a tool for this that's called Marathon. Marathon is a way to very easily write, run, and even install Swift scripts using the Swift Package Manager. But it takes away all of the complexity that you usually have to deal with in terms of setting up the package and running it. You can just run a single file, just like you used to do. So what I'd like to do now is to give you a quick demo of what it is to work with Swift scripting using Marathon. So I'm going to jump over here to the command line. I'm going to just do that. All right. So here I am now on in my terminal in a scripts folder that I have. So using Marathon, you can very easily add packages that you can then use in your scripts. In this case, I've already done so to avoid any Wi-Fi networking issues. So if I now run Marathon list, I can see which packages I have at my disposal. Here I have files, shellout, and xgen, which are three frameworks that you might find useful if you're doing scripting. And you can easily add new ones, and I'm going to show you that in a while, how to do that as well. But for now, let's create a script. What I want to do now is that I really love playgrounds. I think playgrounds are super awesome, and I love just being able to prototype things using them. But it can require quite a lot of setup to create a playground and add a dependency to it. So I really want to create a script that does that for me. So I could go into any folder that I wanted that contains an Xcode project, run a script, and it would open a playground. That would be pretty cool. So let's do that. I'm going to run Marathon create, which is going to create a script for me. We can call it play, because we're going to play with some of our libraries. And I'm going to run that. That's going to create a script, and it's going to open up Xcode. So what this has done now under the hood is to generate a package with all of our dependencies that we have. So we can see here that we have xgen, shellout, and files. And here we have our main.swift source file that we can use for scripting. But we didn't have to do any of that ourselves. It was all done automatically by the tool. So what I can do here now, I can start coding. And I have code completion and everything that I'm used to in a normal Swift app. So I can import files. Oh, not files. I can import shellout. And I can import xgen. All right. So what we want to do now is we want to first of all search for an Xcode project. And this is what we're going to use files for. So we're going to start iterating over all the folders that we have in the current folder. So I'm going to say for folder in file system current folder dot subfolders. I'm just going to move that away so we can easily see what's going on. And now I want to check that the current folder that we're operating on is in fact an Xcode project, because an Xcode project is actually a folder that you might know. So I'm going to check if folder.extension equals Xcode proj. If it is in fact an Xcode project that we found, we want to create a workspace. So this is where I'm going to use xgen. I'm going to say let workspace equals workspace. Sorry, I just need to know typing is hard, as we know. And here I give it a path. I'm just going to call it play, just to make it simple. And now I want to add a playground to this workspace. To do that, I just call workspace.addPlayground, and then we have a playground. Pretty simple. Now I want to add my Xcode project to this workspace. So I'm going to call workspace.addProject at folder.path. So this way I've now taken my Xcode project and I've added it to the workspace. Finally, let's generate it. So I'm going to call try workspace generate, and that's going to generate it at the path that I specified, which is play. And then since I'm done, I can just exit the application. So we're going to be done and we can just exit. So that way, yeah, we don't need to continue the iteration. All right, so our script is done. We're done with that. So we can now close Xcode. And we're going to now run this script. So I'm going to move into a folder where I have a project. So I'm going to move into my folder for unbox. Or not core, sorry, code. Called unbox. And here I have an Xcode project. So I'm going to run this script here. So I'm going to say marathon run. And I'm going to go into scripts and then play.swift. And that's going to run this script now. It's going to compile it in the background. And then it's going to run it. So what's going to happen? Nothing's going to happen. We did a mistake. Let's see. Marathon edit. Let's go back and edit our script. So we're checking if the folder's extension is Xcode Pro. Yeah, that's great. We create a workspace. Oh, you know, I made a very, very big mistake, of course. You know, it's always the demo effect. You always have to make one mistake. I'm not opening this. I'm generating the playground so we can actually see here if we go and run, if we go to code unbox and we run ls, we can actually see that I have a play.workspace there. But I want to open it also because otherwise the script loses a bit of its utility. And this is where shellout comes in. So shellout enables you to run native command lines from a Swift script. So I'm just going to say try shellout, open, and then I'm going to just say workspace.path. There we go. And that's going to just open this workspace that we just created. So I'm going to again close. And then close that edit mode, and then do the same thing again. I'm going to say marathon, run, scripts, play. And that's going to run our script, and now we have a playground. And here we have now unbox, so we can very easily just import unbox and get coding. So here you could see we could just very easily, in just a couple of minutes, couple of lines of code, create a very useful utility for ourselves that we can just use whenever we need a playground. So that's pretty cool when you want to run scripts, but also for good performance and to be able to run a script from anywhere, you might want to install it. And Marathon provides this as well. So we can run marathon install and give the path to the script that we want to install, which would be scripts play in this case. And that's going to compile the script into a release binary, and it's going to move it to user local bin. So that's going to happen in just a second, and there we go. So now we've moved users John scripts play.swift installed into user local bin play. What this means is that I can now go into another folder, for example, where I have wrap, and I can just say play now. I don't just need to prefix it with marathon run. It's just a normal command line tool that you can use from anywhere you want, and now I have another playground. So you see it becomes very, very quick now. I can just run play anywhere I want, and I get a playground, which is pretty cool, I think. All right, so let's jump back to the slides. So you saw there that I was using some libraries, but I was also using some APIs from Foundation in order to do scripting. And some of those APIs that are very useful for scripting, for example, are accessing the arguments from your command line. This is just an array of strings, and the first one will always be the execution path. So it's good to always start at index 1. When you need to access things from the network, you can just use data contents of URL. This is something that you probably wouldn't want to do if you're building a real app. You don't want to block the main thread while you're loading some assets. But in a script, this is great, because scripts are just executed from top to bottom in a sequence. So then you can just use this. If you need to use some form of async operations, you can use dispatch semaphores. And those semaphores enables you to do multiple operations and then signal when you're done. Finally, if you need to do output, you can just print. And if you need to exit your script, you can use exit. So those are some APIs that I find pretty useful when it comes to scripting. All right, so that's it. That's what I had for you today. If you want to keep in touch with me online, I'm at John Sundell on Twitter. I'm also at John Sundell on Medium. And all the tools that you saw today, Marathon, XGen, Files, Shellout, they're all available open source on GitHub that you can use if you want. I've also made them in a way that they would be pretty easy to import from any other tool that you might want to build. So I would really, really love to see you building even more tools using these, or maybe be inspired by these or something like that. Finally, I just want to say that, so why am I so excited about this kind of stuff, and why am I building things like Marathon and these scripting tools? I think that as a developer community, especially in Swift or as Apple developers, we're kind of relying a little bit too much on Apple to innovate in the developer tool space. We're always waiting for a new version of Xcode to fix everything. We're always waiting for what they're going to do next. But it turns out that there are so many tools that we can build, especially in terms of Swift, that we want to use ourselves. We don't have to wait for Apple to innovate. We can just do it ourselves. And if we can make it open source, then anyone can contribute, and you know, we can just share our ideas and make something great. So I just want to finish this off with one quote, and this is kind of, I think, sums up my thoughts when it comes to scripting and automation. And that is that anything that a human has to do more than 5 times is way better done by a script. Thank you very much.
So, any questions? No questions? Hi, once again.
Hi.
Question about Shellout.
Yeah.
Is it agnostic of interpreter type?
It uses
that shell.
It uses Bash.
It's Bash.
It's Bash, yeah.
Dependence Bash.
Yeah.
For other types, you should write your own Shellout. Yeah.
You can, or you can, if you want to submit a pull request that would like give an option to use a different shell, then I would love to accept that.
Okay.
Yeah.
Thank you.
Thank you, John. I have 2 questions.
Okay.
First, it's easy. I think if you use package manager and Bash, then you could run it also on Linux.
Of course, yeah, absolutely. And Marathon also runs on Linux, by the way.
And second question, for example, as you mentioned, sometimes we want to use core graphics and other, let's say, frameworks provided by Apple. Unfortunately, they are not supported package manager. So is Marathon somehow support to run script locally, but using these frameworks or not?
What do you mean locally, like on your machine? Or?
I mean, if I need some cases just for iOS and macOS, then I could import some libraries that on my local machine.
Right, yeah. I mean, you could write like a wrapper. It's not provided out of the box, but you could write a package that basically, like, if it's Linux, you import this framework and you do this stuff, like basically an abstraction around core graphics.
And it would generate Bash script.
Sure, you could do that. Yeah.
Thank you.
Any other questions?
Well, okay. If you want to discuss something, please come to discussion zone number 3.
Yeah, and if you want to see more demos or you want to like hack on some scripts together, I would love to do that. So just grab me in the corridor or whatever, and we can hack on something together. Thanks again.